All right, so this is going to be a pretty quick lecture. I just want to discuss very briefly the option you have of plotting your data using logarithmic frequency scaling or linear frequency scaling. So these two plots that you see here are exactly the same data, exactly the same wavelet frequencies, same baseline normalization. The only difference between them was at the very, very end of the plotting when I used logarithmic scaling here and linear scaling here on the right. And so, so it's a little bit striking at first that these two are showing the same data. You can see the frequencies here, so each tick goes in 10 hertz. And over here on the left, each tick, well, this one starts out as 2 hertz, and then it's a 4 hertz jump, and then a 10 hertz jump, and a 20 hertz jump. So each tick is actually doubling almost, so it's a logarithmic scale. So this time frequency feature here, this theta thing, that's the same as this little guy down here. And this beta band suppression over here corresponds to this. And here you can see I have these arrows in here. This shows that this, you know, it looks like a little tiny blip in the logarithmic frequency scaling plot. It appears to be a bit more prominent in this linear frequency scaling, although they are exactly the same data. It's just a little bit stretched. Here, I guess you could say the higher frequencies are a bit more stretched here, and the lower frequencies are a bit more stretched here. So, of course, both are fine, and you can do whichever one you prefer. In general, if you are highlighting the lower frequency activity, or if the lower frequency activity is more relevant for your study, then I would recommend going with the logarithmic frequency scaling, really just because visually the lower frequencies are a bit more prominent. You know, if you show this entire map here on the right, and then you try to explain to people that they should really only pay attention to this little tiny sliver all the way at the bottom, people are going to get very distracted, and you know, you would look at this and say, well, what about all this stuff? This seems to be all the interesting stuff, and then this is just this tiny little thing down here. But of course, if you show it on a logarithmic scale, then this lower frequency activity is much more prominent. Conversely, if you are focused more on the higher frequency activity, then it's probably better to prefer a linear frequency scaling, mainly just because that stretches out the higher frequencies. But you know, this is really just a matter of personal preference. Okay, so if we switch to MATLAB here, so in the script I'm going to show you how to plot these things, but I also wanted to show you a little bit of what my scripts tend to look like. So a lot of the scripts that I have and that I give out for teaching are not really in the same format of the scripts that I use for my own data analyses. But this one is a little bit more like a kind of, you know, production quality script. So at the top I have all the parameters that I specify. So these are soft-coded parameters. These are very easy to change if I want to try some different frequency range, for example. And then further down is more parameters that are specified, and these are usually things that I don't want to touch, that I don't want to change in different analyses. Okay, so we can run that. And here's where the convolution actually takes place, and all this stuff you will recognize from previous lectures and previous scripts. Yeah, I think there's nothing new here. And now we get to the plotting. And so now you can see I'm reproducing, well, conceptually the same plot as in the slides. This is a different electrode from what I use. But you see the same thing. So we have this feature, like this upper alpha burst in, which electrode was this? This was PZ. This kind of upper alpha burst here, and it's the exact same thing down here. It just, here it appears very prominent and front and center, and here it looks like it's a bit, I don't know, less important or something like that. One thing I wanted to highlight here and give you code for is the difference in between two plotting functions in MATLAB. One is called contourf, which is just like a derivative of the function contour, And the other one is imagesc, which is a derivative of the function image. It just scales the color values. So these two plotting functions work a little bit differently from each other. And particularly with imagesc, it's really important to understand how the function works and to use it correctly. This is particularly important if you have logarithmically scaled frequencies like what we do. Here I have logarithmically scaled frequencies, and so if you just plot use imagesc, then the frequency axis is going to be incorrect, because this function is basically not really paying much attention to the actual input. It just plots everything on a linear scale no matter what. And so you can see this feature here, this upper alpha thing. Here you see, it's around 12 hertz or so. Here you see it's around 12 hertz. Here you see it's around 12. And here is the same plot, of course. It's the same data. But it looks like this feature is 30 hertz. So this is totally wrong. I hope I convince you here that this is the wrong y-axis label. I guess this could just be singular, but anyway. So this is a very tricky thing it's a tricky aspect with the function image scale. Partly for that reason, and partly because image scale shows these more pixelated pictures rather than the smoother, a little nicer looking pictures that are designed by contourf. I tend to prefer the function contourf. Of course, imagesc is fine as well if you prefer it. Just make sure, it's very important to make sure that you are accurately scaling the y-axis. So you're not completely, this would be like a really horrible misinterpretation if you actually reported this to be a 30 hertz response, when in fact it's really just a 12 or 13 hertz response. So I'm not going to go through this code, but you can. I guess the most important one is this, because this is where it's actually done accurately. So anyway, I hope you found that mildly interesting. This is yet another aspect of time frequency analyses where you get to have some freedom, you get to choose something, and which option you choose is really more about your personal preference than about anything that's really sort of mathematically or statistically appropriate. Good. So see you in the next lecture.